In this video we will explain the PLC Programming Assignment.
Cylinder A extends to move the mold into place and hold it there, and cylinder B extends to press the cheese. There is a time delay of 4 seconds at the beginning of a cycle when both cylinders are retracted. This is for the operator to remove a mold which is already pressed and put in a new mold. The pressing movement should be repeated 3 times. The movement is thus as the graphs shown.
Now, the ladder diagram will be explained.
In the software, the system was successfully connected to the remote lab using the corresponding IP address. In order to determine the correct system behavior, the process was divided into 5 segments represented in the following ladder diagram. Both pistons start retracted. In segment 1, the state of the cylinder is sensed. When retract, the normally open contact closes, energizing a 4-second timer that leads to the actuation of a solenoid which extends the cylinder A.
In segment 2, a latching circuit is used in order to extend the cylinder B. 2 normally open contacts close as soon as the cylinder A is extended and B retracted, energizing the UV plus solenoid. There are 2 other contacts which are normally closed. The counter contact participates in segment 3, which extends 3 times cylinder B, whereas the B extended contact opens as soon as cylinder B achieves the extended position in order to de-energize the segment and allow further retraction.
Segment 3 is a counter segment. It senses the state of B, adding a count every time B is retracted. As soon as V is retracted 3 times, A will retract 2, closing its normally open contact and setting the counter back to 0.
Segment 4 is responsible for iterating the actuation of B from extended to retracted. The latching circuit senses when B is extended so that the UB- is energized and the cylinder retracts. The normally closed contact is used in order to allow further expansion. Finally, the segment 5 is responsible for the retraction of the cylinder A, and therefore the end of the cycle. The latching circuit will energize UA- as long as A is extended, and the normally open contact counter is closed, meaning B has been retracted 3 times. The normally closed contact A retracted opens as soon as A is retracted, and the system is at its initial state again.
As it can be seen, the first cylinder activates after 4 seconds, then it stays extended, while the other cylinder activates 3 times. After this, both cylinders return to their initial position. The main reason why learning to program PLCs is that it is a system that makes machineries work automatically. It is used practically in every factory, and it is not limited to production machines, as it can also be implemented in water systems and others. Thanks to this assignment, I was able of understanding in a particular way the functioning of this type of PLCs, as well as got familiarized with its user interface. The interface presented by this program allows the programmer to implement in a simple way the ladder diagrams he has previously designed, reducing the effort and time invested. This also helps for an easy understanding of the diagram in case maintenance is needed, as well as it is useful for error detection.
The most relevant aspect of this practice is that electromagnetic systems can control repetitive and simple processes in a very effective and easy way when the logic and functioning of all their elements is understood. As it can be seen, not only did this system need expansion and retraction commands, but also context that deactivated the binary control of the energized solenoids so that the cylinders could expand and retract repeatedly with no major problem. Finally, it was evident that these control elements are highly versatile and viable for industrial processes.
First, talking about the meaning of the most important results, I can conclude that Aquary is one of the most important into them. This is due to the fact that as a small error in the control stage or in the configuration of the parameters of the components can lead to an imprecise behavior of the system. And nowadays, talking about of an error in an industry system means losses of money, and nobody wants that. And also, I can say that I learned that as engineers, it is important to know how the components of a PLC system behave and how the circuit needs to be built to obtain the behavior that we are all looking for those components. This is because knowing the components and knowing how they work will allow us to make a different system that develop any task we want.
After having some lab sessions about pneumatic system, it is definitely a correct way to finish the topic. Being able to visualize how the valves open and close, making the cylinders act, by also visualizing how sensors don't have really a delay. It's extremely interesting and definitely gives me more, gets my interest even higher in the subject.